So in today's class, let's start with a proposition. So the proposition states that if phi and psi are two simple functions which vanish outside a set of finite measure, and if a and b are constants, then integral a phi plus b psi, that will be equal to a integral phi plus b integral psi. And if phi is greater than or equal to psi almost everywhere, then integral of phi will be greater than or equal to integral of psi. So these are type of results we have seen in Riemann integration. So നമ്മൾ normal integration la integral a phi plus b psi will be equal to a into integral phi plus b integral psi. Will say that the same type of result will hold for. So we'll prove that the same type of result will hold for the Lebesgue integral also for simple function. So given phi and psi to be simple functions of a phi and psi measurable ആയിരിക്കും, they will be assuming finite number of values, and we can represent them using the canonical representation. So let us consider the canonical representation of phi and psi. So we'll assume that phi takes a value a1, a2, an in the set capital A1, capital A2, capital AN. അതുപോലെ സൈയുടെ വാല്യൂ b1, b2, bm ആണെന്ന് അസ്യൂം ചെയ്യാം in the sets capital B1, capital B2, capital Bm. So the canonical representation will be phi equal to summation I equal to 1 to n ai into chi of ai, and psi will be summation j equal to 1 to m bj into chi of bj. So these are the distinct values taken by the functions of a1, a2, an ആണ് phi യുടെ values b1, b2, bn എന്ന് പറയുന്നത് chi യുടെ values. Okay. Now let us look at the function a phi plus b psi. Okay. ഇനി നമുക്കറിയാം ഫൈയും സൈയും സിമ്പിൾ ഫങ്ഷൻസ് ആണ്, അപ്പോൾ അത് finite number of values ആണ് assume ചെയ്യുക. So when you take a phi plus b psi, that also will assume a finite number of values. So this is again a simple function which is taking finite number of values, and the values will be aai plus bbj, and these values will be taken in pairwise disjoint measurable sets ai intersection bj. Okay, so in ai intersection bj, the value of phi and psi will be ai and bj respectively. So you look at all the possible intersections. Okay, so നമുക്ക് ഫൈയും ഫൈൻ്റെയും സൈയുടെയും വാല്യൂ ആണ് വേണ്ടത്. So for all I equal to 1 to n and j equal to 1 to n, so consider the intervals of the form ai intersection bj. So on this intervals your function will take the value aai plus bbj. So the function a phi plus b psi, that will be a simple function which takes a value aai plus bbj on pairwise disjoint measurable sets. Since each ai and each bj, the ai's, അതായത് നമ്മുടെ a1, a2, an ഉം sets b1, b2, bm ഉം pairwise disjoint ആയതുകൊണ്ട് അപ്പോൾ അതിന്റെ സബ്സെറ്റ്സ് ആയിരിക്കും ai intersection bj. So these will be again pairwise disjoint, and since ai's and bj's are measurable, this set is measurable. So your function a phi plus b psi assumes the values ai plus bj on pairwise disjoint measurable sets ai intersection aj. അപ്പോൾ അതുകൊണ്ട് നമുക്ക് ഇതിനെ canonical formula represent ചെയ്യാൻ പറ്റും. So the function a phi plus b psi can be represented in the canonical form as, so it can be represented as, so a phi plus bj will be summation I equal to 1 to n summation j equal to 1 to m. So it will be taking the value aai plus bbj in the set ai intersection bj, chi of ai intersection bj വരും. Now this summation നമുക്ക് ഇതിനെ സ്പ്ലിറ്റ് ചെയ്ത് രണ്ടായിട്ട് എഴുതാം. So that will be A summation I equal to 1 to n, then j equal to 1 to m ai, m of ai intersection bj, then b times summation I equal to 1 to n, j equal to 1 to m bi ai intersection bj varum. Okay. Now this we'll call it as equation 1. അപ്പോൾ നമുക്ക് integral a5 plus b side value കിട്ടി. ഇനി we will show that this first sum represents integral phi and the second sum represents integral psi. അങ്ങനെയാണെങ്കിൽ we can say that integral a5 plus b psi will be equal to a integral phi plus b integral psi. So our proof will be complete in that case. So let us look at what is the value of integral phi and integral psi. Mean when you consider the function xi, so xi is defined on the sets b1, b2, bm. So therefore the union j equal to 1 to m bj will be equal to r. So this union will be equal to the set of real numbers. ഇനി നമുക്ക് ai intersection r എന്ന് എഴുതാൻ പറ്റും. So since r is a set of real numbers, ai intersection r will be itself. So ai intersection r will be equal to ai. Now let me represent r as union bj. So you can write it as ai intersection union j equal to 1 to m bj. Now take a union outside. So this will be union j equal to 1 to m ai intersection bj. So this can be written in this form. So union j equal to 1 to m ai intersection bj. അപ്പോൾ നമുക്ക് ai നെ ഈ ഫോമിൽ എഴുതാൻ പറ്റും. Now each of the sets on the right side, they are pairwise, disjoint, and each of them are measurable. So measure of ai will be equal to, by the additive property of the measure of ai will be equal to summation j equal to 1 to m measure of ai intersection bj. So by the additive property of m of ai can be written in this form. So by definition of integral phi, ഇനി നമ്മൾ canonical representation അറിയാമെങ്കിൽ ഇന്റഗ്രലിന്റെ വാല്യൂ summation I equal to 1 to n a into m of ai ആയിരിക്കും. ai m of ai ആയിരിക്കും നമ്മുടെ മെഷർ എന്ന് പറയുന്നത്. This is by the from the canonical representation. So ഇനി നമ്മൾ ഇവിടെ m of ai നമുക്ക് കിട്ടി, ആ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. So we will get summation I equal to 1 to n ai വരും, summation j equal to 1 to m. So m of ai യുടെ വാല്യൂ ഇവിടെ കൊടുക്കുക. അപ്പോൾ j equal to 1 to m m of ai intersection bj. So that will give us summation I equal to 1 to n summation j equal to 1 to m ai m of ai intersection bj. ഇനി similar to this we can start with bj. bj നെ നമുക്ക് bj intersection r എന്ന് എഴുതാൻ പറ്റും. Now r can be written as union of ai's. അപ്പോൾ ഇവിടെ r നെ നമ്മൾ യൂണിയൻ bj ഇതേപോലെ r നെ യൂണിയൻ as എന്ന് എഴുതാം. So that will give us this representation for psi. അപ്പോൾ നമുക്ക് phi യുടെ കണ്ടുപിടിച്ചാൽ psi യുടെ കണ്ടുപിടിക്കാൻ പറ്റും. So integral psi will be summation I equal to 1 to m summation j equal to 1 to m bj m of ai intersection bj. So we have obtained the value of integral phi and integral psi. അപ്പോൾ അതാണ് നമുക്ക് ആക്ച്വലി 1ലും കിട്ടിയിരിക്കുന്നത്. അപ്പോൾ നമുക്ക് 1ൽ കിട്ടിയ ഇതാണ് ഇന്റഗ്രൽ ഫൈയുടെ റെപ്രസെന്റേഷൻ ആയിട്ട് ഇപ്പോൾ കിട്ടിയത്. അതുപോലെ ഇതെന്ന് പറയുന്നത് ഇന്റഗ്രൽ സൈയുടെ വാല്യൂ. സോ substituting this into 1, so we will get integral a phi plus b psi equal to integral a integral phi plus b integral psi. So that completes the proof of the first part of the proposition. The second part is, so if phi is greater than or equal to xi almost everywhere, then we need to show that integral phi is greater than or equal to integral psi. So let us look at the proof of that. Phi is given that phi is greater than or equal to psi almost everywhere. Now let us look at a simple function phi such that phi is greater than or equal to 0 almost everywhere. Phi greater than or equal to 0 almost everywhere meaning when you take the complement that will be having measure 0. So when you take the set of x such that phi less than 0, so measure of that will be equal to 0. So measure of set of x is that phi of x less than 0 will be equal to 0. And now we will actually show that if phi is greater than or equal to 0 almost everywhere, then integral phi will be always greater than or equal to 0. So using this result we can obtain the required result. Okay. So നമ്മുടെ phi assume ചെയ്യുന്ന values a1 a2 an എടുക്കുക. അപ്പോൾ ഈ values നമുക്ക് positive values ഉണ്ടാവാം negative values ഉണ്ടാവാം. So let me assume that the values a1 a2 an minus 1 they are non-negative and an is less than 0. an ന്റെ value negative ആണ്, ബാക്കിയെല്ലാം greater than or equal to 0 ആണ് നമ്മൾ assume ചെയ്യും. So any number of ai's can be non-negative or negative. നമ്മൾ ഈ ഒരു particular case എടുക്കുക. So we are just going to look at what is the that integral is always greater than or equal to 0, whatever is the case. Okay. അപ്പം നമുക്ക് വേണ്ടത് set of x such that phi of x less than 0 ആണ്. ഇവിടെ phi of x less than 0 വരുമ്പോൾ നമ്മുടെ phi assume ചെയ്യുന്ന value an ആയിരിക്കും. So set of x such that phi of x less than 0 will be same as set of x such that phi of x equal to an. ഇനി നമുക്കറിയാം ഇതിന്റെ measure 0 ആണ്, കാരണം phi greater than or equal to 0 almost everywhere ആയതുകൊണ്ട് the measure of this set is going to be equal to 0. So measure of an will be 0. Now since phi is a simple function, its integral value, integral phi will be equal to summation 1 to n an into m of ai. Okay, അപ്പോൾ ഇത് നമ്മുടെ പോസിറ്റീവ് ai's വരുന്ന സം ആണ് and ഇത് നെഗറ്റീവ് വാല്യൂസ് വരുന്ന സം. അപ്പോൾ നമ്മുടെ നെഗറ്റീവ് വാല്യൂവിന്റെ കൂടെ എപ്പോഴും you will have a measure such that the measure is equal to 0. അപ്പം an into measure of an ആയിരിക്കും വരുന്നത്, പക്ഷേ less than 0 ആകുമ്പോൾ the measure will be equal to 0. So therefore this term will be 0 and ഇവിടെ m of ai യും positive ആയതുകൊണ്ട് this sum will be always greater than or equal to 0. So therefore if phi is a simple function such that phi is greater than or equal to 0 almost everywhere, അങ്ങനെയാണെങ്കിൽ integral phi will be always greater than or equal to 0. Now in the first part we have proved that integral a phi plus b psi will be equal to a integral phi plus b integral psi. So let us take a equal to 1 and b equal to minus 1. So a 1 and b minus 1 ആകുമ്പോൾ നമുക്ക് റിസൾട്ട് ഇങ്ങനെ വരും. So we are given that phi greater than or equal to psi almost everywhere. That means phi minus psi is greater than or equal to 0 almost everywhere. അപ്പോൾ നമുക്ക് ഇപ്പോൾ കിട്ടിയ റിസൾട്ട് വെച്ച് phi greater than or equal to 0 almost everywhere ആണെങ്കിൽ integral phi will be greater than or equal to 0. So integral phi minus psi will be greater than or equal to 0. അതിനെ നമുക്ക് ഇങ്ങനെ എഴുതാൻ പറ്റും. So integral phi minus integral psi will be greater than or equal to 0. So that will give integral phi greater than or equal to integral psi. So if phi greater than or equal to psi almost everywhere, then integral phi will be greater than or equal to integral psi. So that completes the proof for the second part of the proposition. Not using this theorem. So if you have phi equal to 0 almost everywhere, we can write it as phi greater than or equal to 0 and phi less than or equal to 0 almost everywhere. If phi greater than or equal to 0 ആണെങ്കിൽ integral will be greater than or equal to 0. Less than 0 വരുന്ന case integral less than 0 ആയിരിക്കും. So combining both